Hi, I'm Parul and you're watching this video by justtutors.com. In this video, we'll be learning about perpendicular from center to a chord in a circle. So before we proceed with today's topic, we have some questions here as warm-up. You can pause this video to try these questions. So in the first question, we have to name minor and major sector in this given circle. So as we know, minor sector is made up of a minor arc. So here in this circle, arc ACB is the minor one. So let's write minor sector in front of it. And arc ADB, the one in red, is the major arc. So that forms a major sector. Our next question is, if two chords subtend angles of 60 degrees each, what can we say about the length of chords? So as we know that if two chords are subtending equal angle at the center, that means they are equal in length. So we can comment about their lengths as being equal. Pat your back if both your answers are correct. Well done. Now let's proceed with perpendicular from center to the chord. Our first property is the perpendicular from the center of a circle to a chord bisects the chord. That means we are given that OM is perpendicular to chord AB. So we can say that angle OMB is equal to 90 degree, and we have to prove that AM, that is this part, equals to BM. So first of all, we'll do a small construction of joining O to A and O to B, and we'll get two radii. Now our next step is to prove triangle AOM congruent to triangle BOM. Now let's see how we'll do that. We have OA equals to OB because they are radii of the circle. Angle AMO, that is this one, equals to angle BMO, both are 90 degrees, and we have OM common to both triangles. So by RHS rule, that is right angle, hypotenuse and side, we have triangle AMO congruent to triangle BMO. Now by CPCT, that is corresponding parts of congruent triangle, we have AM equals to BM. Hence we have proved that the perpendicular from the center of a circle to a chord bisects the chord. Now let's see what is our next property. It says it's just the inverse of the first one. So it says the line drawn through the center of a circle to bisect a chord is perpendicular to the chord. So this time we are given that AB is a chord and AM equals to BM, and we have to prove OM is perpendicular to AB. So to prove it perpendicular to AB, we just need to prove angle BMO equals to 90 degrees. So first of all, we'll join O to A and O to B and get two radii of the circle. Now again we'll prove triangle AMO congruent to triangle BMO. Let's see how we can do that. We are given that AM is equal to BM. We have OM common to both the triangles, and OA equals to OB because they are radii of the same circle. So by SSS, that is side rule, we have triangle AOM congruent to triangle BOM. So now by CPCT, we have angle AMO equals to angle BMO. Now angle AMO plus BMO are supplementary angles, as we can see that they form a linear pair and it will be equal to 180 degrees. So that means angle AMO plus BMO equals to 180 degrees, or as we have already proved that BMO equals to angle AMO, so twice of angle AMO is equal to 180 degrees, or angle AMO equals to 90 degrees. Therefore we have proved that angle AMO equals to angle BMO and they both are 90 degrees. So this gives that OM is perpendicular to AB. Hence we have proved that the line drawn through the center of a circle to bisect a chord is perpendicular to the chord. So based on these two properties, here are some questions for you. You can pause this video to try these questions. And once you are done, please make sure you check your answers from here. Pat your back if both your answers are correct. Well done. Thank you for watching this video. For more, please visit justtutors.com.